Hi everyone, welcome to lesson 7 of polynomials. Today's lesson is called composition of functions. Before we start on today's lesson, we're going to start with this opener question. It says use the graphs of f and g of x to evaluate the following. So we're looking for f minus g at -1. So what you want to do in this case, in this example here, is I'm going to separate these into two functions. So I'm going to rewrite this one big function as f of -1 minus g at -1. And all I'm going to do now is look up both of these values on their respective graphs. F here is this parabola here at -1. We look to be at positive 1, 2, 3, 4, 5, 6. Looks to be at 6 there. And from here, I'm going to subtract whatever g of x is. Well, g at -1, well, here's -1. G of x is -1, 2, 3, 4, 5. So I have 6 minus -5, and of course that gets us to positive 11. In the next example here, I'm going to separate this into two multiplication statements. So this is f at 3 multiplied by g at 3. And so f at 3, again, 1, 2, 3, f at 3 here, we're at -2, it looks like. And g at 3, so 1, 2, 3, g at 3 is positive 3. So again, multiplying these two together, we get -6. And the last example here, we're going g divided by f. So in this case, we're going to write g at 0 divided by f at 0. Let's see what we have. So g at 0 is -1, 2, 3 is at -3. F at 0 is at positive 1. So our answer here, just -3. So that was our opener. In today's lesson, we're going to review composition of functions. So to do that, first off, we got to review what a function is and how it works. So if I had f of 4 in this equation, all I'm going to do is sub in that 4 for every single x and complete the equation. So of course this is 20 minus 9, which is just 11. Over here I'm subbing in a binomial into the function, but that's okay. So we have 5 subbing in x plus 2, close bracket, minus 9, distribute out 5x plus 10 minus 9, and simplify 5x plus 1 overall. So the note here, we can combine functions using another method called composition of functions. This is a algebraic process. The composite function is f of g. So there's always a little circle there, not a dot, it is a circle between two functions. And it's defined by f of g of x. Or you could write it in this variation here. I usually tend to write it this way. The diploma writes it this way. Beware of both. Both are read as f of g of x, as I mentioned, and g, it says here for all x in the domain of g, such that g of x is the domain of f. So we're going to keep in mind what everything's domain is. So let's go. This first example, I gave you f of x and g of x. We're going to figure out f of g of x. So this is the same thing as saying f of g of x. So that means I'm going to take my function g of x and sub it into f of x. So g of x was 2x plus 3, f of x is 1 minus x squared. So let's start off with our sub in. So we have f g of x again was 2x plus 3. So instead of saying g of x, I'm going to say 2x plus 3. And in my function f of x, I'm going to sub in this equation. So here now I have 1 minus bracket 2x plus 3 all squared. There we go. From here, I'm going to distribute and multiply out. So this is the same thing as saying 1 minus 4x squared. I'd have 6x and 6x, which makes 12x plus 9. Of course, there's a 1 minus there, so I'm going to deal with that by switching all the signs around and collecting like terms. That's minus 4x squared minus 12x. This is now negative 9, so you have 1 minus 9, of course, is negative 8. And there we go. That's going to be my new function. In this example here, this is saying take g and have f of x subbed into it. So what is f of x? I can write that out as g, and we're subbing in 1 minus x squared. So in my equation for g, I have 2, and instead of x, I'm going to sub in this 1 minus x squared plus 3. Let's multiply out. That's 2 minus 2x squared plus 3. And of course, we're going to combine like terms and reorder things. So minus 2x squared plus 5 overall. Down here, we're subbing g into g. So, and again, I'm going to quickly rewrite this as g of x. So this is the same thing as saying, well, g of x is 2x plus 3. So I'm going to start off with my 2. Then I'm subbing in another 2x plus 3 into that exact same equation. Let's distribute out. That's 4x plus 6 plus 3. And this is now 4x plus 9. Lastly, over here, we're subbing f into f. So this is f into f of x. Or sorry, f of x into f, that is. So we have 1 minus, instead of saying x, we're going to go 1 minus x squared. And all of that is squared. So on this one here, be careful with your distribution. This in brackets is going to get you 1 minus 2x squared plus x exponent 4. And of course, I'm going to switch around all the signs and combine any like terms I see. The 1 and 1s will cancel. I have minus x to the 4 plus 2x squared now overall. And there we go. In this here, this should have been E. State the domain of all the above functions. Well, in part A, then we had C right below it, B and D off to the side here. In A, I have a parabolic function. It's x squared, degree 2. So my domain, of course, it's going to be x is an element of real. And I'm not writing it out in full today. In set notation, I should, but I'm just cutting down a bit of my work. In C, just because it's right below, this is a straight line. So domain again. Let's do this one in interval notation. So negative infinity to positive infinity. B, again, it's a parabola opening downwards, 5 up, but it doesn't matter. We're going left and right. Is going to be everything from negative infinity to positive infinity for the domain. And the last one here, fourth degree 4 there, opening down. It's going to be a big parabola, more or less, opening down. So again, negative infinity, positive infinity. So all 4 really have the exact same domains. In example 2, we're asking you, given this function f of x and g of x is this one here, square root of x minus 2, find the following, state the resulting domain and sketch the graph. So what is f of g of x? So this is the same thing as saying f of g of x. So we're going to take g of x and sub it in. So this is the same thing as saying f of, and our g of x was square root of x minus 2. And we're subbing that into our equation for x here, or for f of x. So we're going to have square root x minus 2, all of that under the radical symbol, all of that is squared, plus 5. Let's clean that up. Well, squared and square root are going to cancel each other out, so I have x minus 2 left over, plus 5 now. This is now x equals positive 3. And that's what I want to graph, is x equals positive 3. But before I can graph that, I'm going to go back and double check what my restriction might be. Well, I had a restriction here. I had a radical that I subbed in. My radical, the restriction on all radicals, by the way. And let's do that off to the side. Restriction on all radicals are always x minus 2 has to be greater than or equal to 0. So here, x has to be greater than or equal to 2. So if this is my graph, usually I would have had a coordinate here, and then it would have gone up in this fashion here. But in this case here, because we have our restriction, it says x has to be greater than 2, greater than or equal to 2, I'm not going to have any coordinate dots below 2. So here I'm just going to connect my dots. There we go. And arrowhead on the end of it. Done. By the way, the domain of this will still be the restriction as well. So for the next graph, what do we have? So we are doing g of f of x. So we're taking f of x, we're subbing it into g. So what's that going to look like? This is g of x squared plus 5. So we're going to take this x squared plus 5 and sub it in. So what does that get us? We get the square root of x squared plus 5 minus 2. All of that's under the radical. Let's clean that up. That's the same thing as saying x squared plus 3 under your radical symbol. And in this case here, our restriction, we should double check what is x squared plus 3. That has to be greater than or equal to 0. That's x squared has to be greater than or equal to negative 3. If you square it, or if you square root it, it wouldn't work. So really, there should be no restriction here. You can also double check that by graphing it on your graphing calculator. So I'm just going to load up my graphing calculator and graphing to see what our domain restriction might be. So here on my graphing calculator, I'm just going to clear off some old stuff there. I'm going to go square root of our equation was x squared plus 3 and graph this function. And there we go. So this is our function. There should be no restriction on it. Our domain is going to be everything. And again, to graph this one, second trace or second graph and pick off values that you can read cleanly, and try your best to graph this one. For me, I'm just going to copy my graph right in here, and that should suffice. In our next example, example 3, again, we're just doing bigger and more complex substitutions. So here we go. And we're evaluating. So this one here is f of g of 3. So what this is going to look like is f of g of 3. So you have to figure out g at 3 first. Whatever that answer is, you're going to sub it in for f. So let's go. So this is the same thing as saying f of, and g of x is this x 5x minus 9. So I'm going to go 5, and instead of x, I'm going to put 3 there, minus 9. And I need to solve this. This is 15 minus 9. 15 minus 9, of course, is going to be 6. And if I have f of 6, I'm going to sub that into here. This is now 2. 6 squared minus 3 times 6 plus 1. There we go, plus 1. And to solve this, we get 36 and 2 is 72. Minus 18 and plus 1. This gets us to 55 overall. Over here, this one here is a bit more complex, so let's go. We've got g of h of 2. I got 1, 2, 3 brackets there, so 3 brackets closing. So first off, we need to figure out what h of 2 is. Well, it says h of x equals x, so that means if h of 2, that's just 2. Now we need to figure out what g of 2 is. Well, in our equation, we have 5 times 2 minus 9. And again, that's 10 minus 9 is 1. So now I'm looking at g at 1. What is that? Well, g at 1 is the same thing as saying 5 times 1 minus 9. And in this case, that's going to get you negative 4. Down here, we're doing a composition and an addition on top of it. So our composition, we're taking this f of x and we're subbing it into here. So I'm going to do that right away. So I have 5 bracket and f of x was our 2x squared minus 3x plus 1. And I still had minus 9 there to finish off my first g of x there. And to this, though, I'm going to add on, in black here, I'm going to add on another 5x minus 9. There we go. Let's multiply and clean this up. So this is now 10x squared minus 15x plus 5 minus 9 plus this 5x minus 9 again. And again, we want to simplify this and add everything up. So what do we get? I now am at 10x squared. I got negative 15 plus 5 is now minus 10x. And I have negative 9, negative 18 plus 5 is now negative 13. And there we go. In this next example, it's asking us to use a graph to find the following. So this here is f of g of 1. So I want to look at my g graph here, g of x graph. Look for 1 first, so 1's right here. That's a value of negative 3. So that's f of negative 3, because g at 1 was negative 3. And from f, which is this graph here, we're looking for negative 3, 1, 2, 3. Negative 3's right here. Our y value is going to be 1. So there we go. On this next one here, this is now g of 5. So what do we want to do? We're looking at our g of x graph here. We're looking for where 5 is. 1, 2, 3, 4, 5. At 5, we're at 1. And now on the same g of x graph, we're looking at 1. 1 is now at negative 3. And there we go. We're able to read the graphs and figure out our compositions. Last but not least, we have this one here. It says given h of x equals this big function, find two functions f and g so that if you subbed f of g of x equals h of x. So you're basically saying go f of g of x equals h of x. So if you take a look at this equation, what would you have subbed into brackets here? Well, my brackets, most likely, so I have my g of x is what's in my bracket, so that's the square root of x plus 1. And if you took out that x plus 1 in radical sign there, what do you have left over? So f of x is going to be x cubed plus x minus 2, because if you took g of x and subbed it in, you'll get back to that equation there. And there we go. That's the end of our lesson. If you have any questions, please feel free to ask.